Good morning. Let us study today zero field splitting in manganese 2 ion or EPR spectrum of manganese 2 ion. How many EPR lines are observed in manganese 2 plus ion? It is commonly asked in CSIR gate examinations. Then we will also study about the differences between fine structure, hyperfine structures. What are called fine structures? What are called hyperfine structures? The zero field splitting, Zeeman splitting and nuclear splitting diagram of manganese 2 ion is shown here. How the manganese ion with the ground state term symbol S6 sextuple state, we will see further how it is split in the presence of zero field splitting. The splitting energy level diagram is shown here. How it is further split in the presence of applied field. This is again split in the presence of nuclear spin coupling. Nuclear splitting called hyperfine splitting. Okay, fine structure. This is the EPR spectrum obtained from the energy level splitting diagram. There are three important parameters obtained from the EPR spectrum of manganese 2 complex, manganese 2 ion. The G value is obtained by using this diagram. The zero field splitting is obtained by using this diagram. Again, the hyperfine splitting is obtained. How it is obtained I have shown here from the EPR spectrum. Manganese ion has D5 electronic configuration with 5 unpaired electrons. Therefore, S 1 by 2 plus 1 by 2 plus 1 by 2, there are 5 unpaired electrons. Therefore, the total spin S equal to 5 by 2. The spin multiplicity is 2s plus 1 equal to 6 sextuple. The ground state term symbol of manganese 2 plus ion is S6, S sextuple state. Therefore, there are 6 spin states. There are 6 spin states, minus 5 by 2, minus 3 by 2, minus 1 by 2, etc. and are labeled as plus or minus 1 by 2, plus or minus 3 by 2, plus or minus 5 by 2. There are 3 Grammes doublet. This is the S6 state. The manganese ion in the gaseous state does not split due to zero field splitting, whereas manganese ion in the crystal field, it splits into 3 levels, 3 degenerates to give 3 degenerate levels, doubly degenerate levels, known as 3 Grammes doublet. We have already studied for odd number of unpaired electron species. The ground state is doublet called Grammes doublets. Further, in the presence of zero field splitting, further in the presence of Zeeman splitting or in the presence of magnetic field, it splits into these 3 doublets, further split into 6 energy levels by the application of magnetic field. Now let us see what is called fine structure, what is called fine splitting. The transitions between these 6 levels, the transitions observed between these 6 levels to give rise to 5 resonance lines using the selection rule, EPR selection rule, delta ms equal to plus or minus 1. Based on the selection rule, EPR selection rule, delta ms equal to plus or minus 1, the transition between minus 5 by 2 to minus 3 by 2 is allowed. whereas the transition from minus 5 by 2 to minus 1 by 2 is not allowed based on the selection rule. So there are 1, 2, 3, 4, 5. There are 5 resonance lines are observed due to zero field splitting in the presence of applied field. These set of 5 lines observed in EPR spectrum is called fine structure or fine splitting. Okay. Now let us see what is called hyperfine splitting. There are 1, 2, 3, 4, 5. Okay. Zero field splitting is obtained from this. Each line, each resonance, each one of the 5 resonance line further split into 1, 2, 3, 4, 5, 6 sextet to give each of the line gives a sextet due to the interaction of electron coupling with the nuclear spin, electron spin coupling with the nuclear spin of Mn55 I equal to 5 by 2 called hyperfine splitting. Therefore 5 into 6 there are 30 lines are observed in the EPR spectrum when D is greater than A. Suppose D equal to 0, then only 6 lines are observed. D equal to, then 6 lines are only observed. We will see further. So overall, the fine structure, fine splitting occurs mainly due to zero field splitting. On the other hand, hyperfine splitting occurs due to the interaction or coupling of electron spin with the nuclear spin. In the above case, in the manganese 2 plus, the zero field splitting is very much greater than A. Then 30 lines pattern, 30 lines are observed in the EPR spectrum of manganese 2 plus. We have seen in the previous diagram. If suppose D is equal to 0 or D is less than A, then only 6 lines are observed in EPR spectrum. They will ask you how many EPR lines are observed in manganese 2 plus if D is greater than A in various competitive exams. If D equal to 0 in the manganese 2 plus ion, how many lines are observed in the EPR spectrum? Then you will be able to answer how many lines will be observed based on D greater than A or D equal to 0. And also we understood now what are called fine splitting and what are called hyperfine splitting. Thank you for watching. In this, how each fine structure line is split into each fine structure line split into 6 lines 1, 2, 3 because of the transition from plus 5 by 2 to minus 5 by 2 plus, see, in the case of NMR, plus 5 by 2 is the ground state, as I have already told. In the case of EPR, minus 5 by 2 is the ground state. Okay, so this is due to nuclear spin splitting. Therefore, plus 5 by 2 is the ground state. You see, this is plus 3 by 2 to minus 3 by 2. Plus 3 by 2 to plus 3 by 2. Therefore, delta Mi based on the delta Mi equal to 0 selection rule, there are 6 lines 1, 2, 3, 4, 5, 6. There are 6 lines observed for each of the fine structure line. Okay. Thank you for watching.